So we're going to continue on through these examples. Write the equation for each one of the rational functions graphed below. Now the first two seem a bit intimidating, and the last one has that point discontinuity there. Let's start off with the first one. Now how we're going to build this is we're going to look for the x-intercepts and use those to build the numerator. Then we're going to look for the vertical asymptotes, and we're going to use those to build the denominator. From there, we'll look at where the horizontal asymptote is and then add that piece of information in. So, starting off, I just have to quickly select my pen here. And starting off, we know that the x-intercepts are going to occur, and it could be a bit hard to see, but I have an x-intercept right there at 1, and I have another x-intercept right there at -4. So that's going to give me x plus 4, and then that's going to give me x minus 1. So I get that my two x-intercepts, one's at -4 and one's at +1. From there, my vertical asymptotes occur when x is at plus or minus 2, so that's going to give me x plus 2, x minus 2 in the denominator. Now, if we look at this, I could expand this out if I want, but we need to find a way to get that horizontal asymptote in there. So let's expand this out and take a look at what we have. I get x squared plus 4x minus x, plus 4x minus x minus 4 all over x squared minus 4. Which is going to give me x squared plus 3x minus 4 all over x squared minus 4. Now what we notice right here is that I have that horizontal asymptote at y equals -2. But up top when I look at this, I'd see that the horizontal asymptote is equal to +1. So all that I'm going to do is I'm just going to introduce a -2 factor into my top. So that will give me -2x squared minus 6x plus 8 all over x squared minus 4. And that one is done. Moving on to the next one, just sort of gonna build a little bridge there to block it off. This one is going to go by a little bit easier. We see that I have my one x-intercept at +1, so that's just going to give me x minus 1 on the top. From there, I have my vertical asymptotes, one's at -1, so x plus 1, and the other one is at 1, 2, 3, 4. So it'll give me the x minus 4. From here, looking at this, we're actually done. And the reason why is if we look, we see that the horizontal asymptote occurs at 0. My power in the numerator is less than the power in the denominator as I currently stand, because here it'll be x and there it'll be x squared. So that means that I have a horizontal asymptote at 0. Thus, all of my necessary conditions are met. If you guys want, you can expand this out, but it's just sort of the same either way. Now, moving on to my last one. There's a couple of different ways that I can do this, but I'm actually going to stay consistent with the way that we've been doing this leading up until this point. Looking at this, and I know these numbers are a bit hard to read, but if we zoom in, we can kind of see that that's trying to be a 1 right there. So that tells me that I have my horizontal asymptote at y equals 1. And the same thing goes for that vertical asymptote. I have that vertical asymptote at x equals 1. Additionally, zoom in, we can kind of see that that's a 3, and I see that I have that y-intercept at 3. So we have a lot more information going on right here. First of all, I'll put my x-intercept in. My x-intercept is just going to be x minus 3. My y-intercept's not going to come into play quite yet, but now I'm going to put my vertical asymptote in. So I get the x minus 1. Now, interestingly in this one, we're given a point right here. And since we're being given that point, I need to check to see if I have to add an a value in to make sure that that point works on my graph. So we're going to go y equals this, and then I'm just going to put an a value right here to see how this works. I go 3 equals a, and then I'm going to go, well, the point that I've been given is 0, 3, so 0 minus 3 all over 0 minus 1, which will give me 3 equals 3a, or a equals 1. Now, subsequently, we could have analyzed this and looked at the horizontal asymptote as well, but we were very clearly given that point, so I felt it necessary to bring that up. So currently, my equation sits at y equals x minus 3 over x minus 1. Well, I've taken into account the horizontal asymptote, I've taken into account the vertical asymptote, and I've checked to make sure that the point works. But what I also have is I have that point of discontinuity right there. And we notice that on my point of discontinuity, my x value is equal to 1. So to add that point of discontinuity in, all that I'm going to do is I'm going to introduce that factor into the game. It's at negative 1, so we're going to go x plus 1 all over x plus 1, which we could see would very easily cancel out in a second. And as such, I've added my point of discontinuity into this. So, in terms of this question, we're actually done right now. Next thing, we're going to move on to these questions, and then we will be done this lesson for today.